Hi students, welcome back to Physics for All YouTube channel. In today's session, I am going to explain you about comparison of simple cubic, body-centered cubic and face-centered cubic structure. This question is important for the essay question in the upcoming university and examination. As per the definition itself, first of all I am going to define you about simple cubic structure. In simple cubic structure, each atom is occupied at each corner of the unit cell. Therefore, in this unit cell, 8 atoms are occupied at 8 corners of the unit cell. This is about number of atoms present in the simple cubic structure is equal to 8. Now, these corner atoms are occupied along the edges of the sides of the unit cell. Therefore, if you can take any two atoms on any side, two atoms are nearer and equidistant to each other. Therefore, atomic radius and nearest neighbor distance relation can be written as R is equal to A divided by 2. Now, because of this reason, each and every corner atom is shared by the 6 surrounding unit cell. Therefore, coordination number for the simple cubic structure is 6. Now we have to calculate effective number of atoms in this unit cell after sharing. In simple cubic structure, each corner atom is shared by 8 other atoms of the unit cell. Therefore, the share of each corner atom is equal to 1 divided by 8. Similar type of atoms are 8. Therefore, 8 into 1 by 8 that is equal to 1. Therefore, after sharing to the neighboring unit cell, the number of atoms per this cell is equal to 1. Now we have to calculate packing fraction. As a definition of packing fraction, the ratio between volume of all atoms in a unit cell to the total volume of the unit cell. Now we can convert this definition into equation form. We can written in the form of n into 4 by 3 pi r power 3 divided by a power 3. Now in this equation of packing fraction, substitute n is equal to 1, then r is equal to a divided by 2, and simplify this equation. We can get packing fraction of simple cubic structure is equal to 0.52. Example for the simple cubic structure is polonium. Now after the completion of simple cubic structure, now we can discuss about another structure that is called as body centered cubic structure. As the body centered cubic structure. Now in this body centered cubic structure, you go through the figure carefully. Now in this body centered cubic structure, in addition to the 8 corner atoms, one more atom is occupied exactly at the center of the body. Therefore, this is called as body centered cubic structure. Now coming to the number of atoms in this unit cell, number of corner atoms is equal to 8. Number of body centered atoms is equal to 1. Now this body centered atom is in contact with the 8 other corner atoms of the unit cell. Therefore, the coordination number for the body centered structure is equal to 8. Now after the calculation of coordination number, now next we have to calculate relation between the atomic radius and nearest neighbor distance. To calculate this relation, we have to consider geometry of the BCC. Already we discussed it in the previous presentation. For better or complete information, you can refer my previous videos. You will get the clear information about relation between R and A. Now from that relation, we can write R is equal to root 3 A divided by 4. Now we have to calculate effective number of atoms in this BC structure is equal to 2. Now how will get 2 out of the 2? One atom is at the corner after sharing and other atom is at the center of the body which is not shared by the any another unit cell. Therefore, total number of atoms after sharing is equal to 2. Now we have to calculate packing fraction. Packing fraction is equal to total volume of the unit cell divided by the total number of the according to the definition, we are writing n into 4 by 3 pi r power 3 divided by a power 3. In that equation, substitute n is equal to 2 and r is equal to root 3a divided by 4. By calculating this value, packing fraction of BC structure is equal to 0.68. Example for the BCC structure is sodium, chromium and potassium are the example for the BCC. Now we will discuss about the FCC. Now as per the FCC definition indicates that face is centered cubic structure. In face centered cubic structure, total number of carbon atoms is 8. These atoms are occupied at the 8 corners of the unit cell. In addition to the 8 corner atoms, 6 more atoms are occupied at the center of each face. Therefore, this is the first face centered atom, second face centered, it is the third face centered, fourth face centered, and it is the fifth face centered. At the back side of this face, one more atom is occupied. Therefore, total number of face centered atoms are 6. This face centered atom is in contact with the 4 corner atoms in each face. Therefore, let us say this example. Now, this face centered atom is in contact with the 4 other corner atoms in this face. Therefore, this face centered atom is nearer and equidistant to the 4 atoms in its own plane, 4 atoms in its above plane, 4 atoms in its below plane. Therefore, 4 plus 4 plus 4. Therefore, 12 is a coordination number for the FCC structure. Now, after calculation of coordination number, next we have to calculate relation between the atomic radius and nearest neighbor distance, which you can calculate using the geometry which already discussed in a previous slide. You can go through that slide. We'll get the relation between R and A, which can be written as R is equal to A divided by root 2. Now we have to calculate effective number of atoms in FCC structure after sharing that can be found in is equal to 4. Out of the 4 atoms, 1 atom at the corner after sharing and 3 more atoms are available at the center of the each face. Therefore, total number of effective atoms in FCC structure is equal to 4. Now we have to calculate packing fraction. As discussed earlier, packing fraction is defined as a ratio of volume of all atoms in a unit cell to the total volume of the unit cell. Now by substituting n is equal to 4 and r is equal to a divided by 2 root 2 in the equation of packing fraction, we can get packing fraction is equal to 0.72. Example for the FC structure is equal to aluminum, silver, copper and gold are the example for the FCC structure. This is a comparison of simple cubic, body centered and face centered cubic structure. Please watch this video completely for getting good marks in the upcoming examination. Please subscribe my channel, share to your friends. Thank you for watching my channel. Thank you.